today we are going to go through solving absolute value inequalities. So we've solved simple inequalities, compound inequalities. Today we're going to do absolute value inequalities. So solving absolute value inequalities. To solve, we're solving absolute value of AX plus B is less than C. And this is just for C values greater than 0. Okay, because C has to be a positive in order for this to go. You're going to have two inequalities. AX plus B is less than C, and AX plus B is greater than negative C. Okay, so we reverse that, and we change the sign of that. So we made it the opposite. Okay, so that is the same as one long inequality. Negative C is less than AX plus B less than C. So I think you will find it easier whenever you have an and. Okay, whenever you have an and, to just make one long inequality. Okay, so less than means and. So however you want to remember it, I just always remember less than. So when it's a less than, when this here at the beginning, the absolute value is less than C, that's going to be an and statement. Okay? If we're solving the absolute value of AX plus B is greater than C, again, when C is greater than 0, so C is a positive, this one is going to be an or. So it's either going to be AX plus B is greater than C, or AX plus B is less than negative C. So this one's going to be two separate inequalities each time. Okay, so whenever you have greater than, it's an or. Okay, so again, however you want to remember it, I just remember great or. So whenever you have an absolute value and it's greater, that's going to be an or. So you're going to have two separate inequalities. All right, so if I'm solving this one, first thing I want to do is look here. Okay, so that inequality symbol is less than, so I know that that's going to be an and. Okay, so when it's an and, I'm going to take the opposite of 8 and put it out front. Then I'm going to have, so negative 8 is less than x plus 2, which is less than 8. So it's one long inequalities. Because if you notice, if you did the two separate ones, you'd have x plus 2 is less than 8, and x plus 2 is greater than negative 8. And if you notice, this here is the same as this. Okay, it's just that we flipped it because the negative 8 is out in front. Okay, so I think you'll find it easier each time to make one long inequality like we have here. Okay, then if you're solving it, okay, this time instead of having two sides, we have three parts. Our variable's in the middle, x plus 2. So again, our goal is always to isolate the variable. So if it's x plus 2, we subtract 2. When I subtract 2 from the middle, I also have to subtract 2 from the outer edges. Okay, so negative 8 minus 2 is negative 10. So I'm going to have negative 10 is less than x, which is less than 8 minus 2 is 6. So there is my inequality. Now, if I'm going to graph, if you do it the long inequality way, it makes it a lot easier when you graph. So I'm going to come over to negative 10. Okay, negative 10 is less than x, so that means x is greater than negative 10. And then it says x is less than 6. So I put an open circle at 6 because, again, it's just less than. It's not less than or equal to. So open circle. And if x is less than 6, it's going to go here. Okay, so that means the solutions to this inequality have to be greater than negative 10 and less than 6. So any number in here would be a solution to our original problem. All right, if we're moving on to the next one, we have the absolute value of, so that is the same as a fraction. So the absolute value of y divided by 3 greater than 2. So again, I look at the inequality symbol, and it's great or, so that means it's an or. Okay, so when it's an or, I'm going to have my first inequality, y divided by 3 is greater than 2. So I just rewrite it without the absolute value. Or y divided by 3, I have to switch the inequality symbol and the sign of the number. Okay, so we had to switch the inequality symbol and we had to make the number the opposite. Okay, once you've done that, now I just solve. So I have y divided by 3, so I'm going to multiply both sides by 3. So I'm going to get y is greater than 2 times 3 is 6. Or I come over to the other inequality, same thing, y divided by 3. So I'm going to multiply by 3. So I'm going to have y is less than negative 6. So there's your answer. Now if you're going to graph, again, just put 0 as your reference. So y is greater than 6. So again, it's an open circle at 6 because it's just greater. It's not or equal to. And if y is greater than 6, I know I'm going to shade to the right, so everything to the right. If y is less than negative 6, I'm going to start at negative 6, again with an open circle, because there is no or equal to on it. Okay, and if y is less than negative 6, it's going to go to the left. All right, so there's a simple one of each of those. If we're going to practice, all right, so again, I'm going to look here. If it's greater, that's an or. So I know I'm going to have two separate problems. I'm going to have y minus 3 is greater than 2, or y minus 3 is less than negative 2. So again, on that second one, you have to flip this inequality symbol. You also have to make that number the opposite. All right, now I'm just going to solve. So I add 3. So y is greater than 5. Or this one, I'm going to add 3. Y is less than 1. So there's your answer. Again, if you wanted to graph it, start by putting a 0 for your reference. And if y is greater than 5, open circle, shaded to the right. Or y is less than 1, open circle on 1, shaded to the left. So on those ors, it pretty much means every number works except for the numbers that are in there. Those numbers would not work. Okay, so for instance, let's say I tried 3 in the original problem. So the absolute value of y minus 3, so if I put a 3 in there, I'd have the absolute value of 3 minus 3 is greater than 2. 3 minus 3 is 0. Absolute value of 0 would be 0. Is 0 greater than 2? No, it's not. So when I tried 3, and 3 is right here in the middle, it did not work. And it shouldn't work. Okay? But everything out here works, and everything out here works. All right, so this one's a little different. Okay, so this one, we don't have the absolute value by itself yet. And I'm going to go ahead and make this an or equal to. So on your paper, go ahead and make that or equal to. That way we can show you all of those. First I need to do is isolate the absolute value. So I'm going to add 4 to both sides. So now I have the absolute value of 3 plus r is less than or equal to 4. Okay, so now that I've done that, I have the absolute value by itself. So I look here, okay, that's less than, so that means it's an and. So when it's an and, you're going to have a long inequality. So the opposite of 4 is negative 4, so I'm going to put that in the front, and then I'm just going to write it. Less than or equal to 3 plus r, less than or equal to 4. So now when I'm solving, the r is in the middle, so I need to get the r by itself. So it's a positive 3, so I subtract 3 from all parts. So negative 4 minus 3 is negative 7. Less than or equal to r, less than or equal to 4 minus 3 is 1. Okay, so there's my inequality. If I'm going to graph it, again, I'm going to put 0 for my reference. So at negative 7, it says negative 7 is less than or equal to r. So that's going to be a filled in circle because it's or equal to. So if negative 7 is less than or equal to r, that means r is greater than or equal to negative 7. So that's going to go this way. And then it says r is less than or equal to 1. So there's my 1, less than or equal to. So it's going to be a filled in circle. So it's going to be any number in between. Okay? So let's say I pick a number. Let's say I pick negative 1. I'm going to plug negative 1 in to the original and see if it works. So I have the absolute value of 3 plus negative 1. Absolute value minus 4 is less than 0. So if I'm doing this math here, 3 plus a negative 1, 3 minus 1 is 2. So the absolute value of 2 minus 4 is less than or equal to 0. Absolute value of 2 is 2. So 2 minus 4, less than or equal to 0. 2 minus 4 is negative 2. Then you're asking yourself, is negative 2 less than or equal to 0? Yes, it is. So when I tried negative 1 here, it did work. And it should have worked because it was in the shaded region. All right, now we're getting on to some that are a little bit longer. So again, our goal is to isolate the absolute value. Okay, so if you want to press pause, take a couple minutes and try to solve it, and then come back and see how we did. All right, let's solve it. So remember, 3 times the absolute value plus 10. So it's kind of like this problem, 3 times something plus 10. So if I'm doing that, I'd want to subtract 10. So that's the same thing I want to do over here. Subtract 10. So now I have 3 times the absolute value, 2x plus 5 is less than or equal to 27. I need to get the absolute value by itself. So we divide by 3. So now I have the absolute value of 2x plus 5 is less than or equal to 9. Okay, now I'm ready to go. Look at your inequality symbol. When it's less than, it's an and. Okay, so I'm going to take the opposite of 9 and put it out front. So I have negative 9 less than or equal 2x plus 5 less than or equal to 9. Now again, I need to isolate the x that's in the middle. So it's a plus 5, so I'm going to subtract 5 from all parts. So negative 9 minus 5 is negative 14. Less than or equal to 2x, less than or equal to 4. Okay, then I need to divide everything by 2. So I'm going to have negative 7 less than or equal to x, less than or equal to 2. Okay, and if you're graphing, put my 0 for my reference. So I'm going to have a negative 7. It's less than or equal, so it's going to be a filled in solid circle. Less than or equal to x, that means x is greater than or equal. And then x is less than or equal to 2. So again, it's greater than or less than or equal. So because it's or equal, it's a solid circle. So when it's an and, it's shaded there in the middle. Okay? All right. Now, let's look at this one. The absolute value of f plus 12 is greater than or equal to negative 4. Okay? So our key here is that this is an absolute value. That's an absolute value. And this is a negative number. So essentially, what you're asking yourself is, when is an absolute value greater than a negative number? Well, it always is, because absolute value is always greater than a negative. Okay, so if you have that pop up, your answer is going to be all real numbers. Okay, so again, whenever you have an absolute value is greater than a negative, it's always going to be greater than a negative because it's positive. So that answer, you don't even have to do the work. You just know the answer is all real numbers. Okay, this one, we have absolute value is less than a negative. When is absolute value less than a negative? Well, absolute value is never less than a negative. Okay, absolute value is never less than a negative. So our answer to this one would be no solution. Okay, so again, whenever you're dealing with absolute value and you end up with a negative on the other side, that should kind of have a light bulb come on in your head like, hey, something's not right. What do I need to do here? And it's actually pretty easy. Just see if it's less than or greater than a negative. So you know your answer's all real numbers or no solution. All right, and we will finish with a word problem. At a certain company, the average starting salary, X, for a new worker is $50,000. The actual salary has an absolute deviation of, at most, $2,500. Write and solve an inequality to find the range of starting salaries. Okay, so if you remember when we were doing absolute value equations, we talked about these type of problems. We always had the absolute value of X minus something, and the number that goes here, okay, the number goes there, was the average or the middle number. So if we're looking back at our problem here, it says the average starting salary is $50,000. So 50,000 would go there. Okay, a key word up here, it says the absolute deviation is at most. So if something is at most, that means it is less than or equal to. Okay, so if it's at most, it's less than or equal to. And how much does it deviate by? It tells us in the problem that it can deviate by up to 2,500. Okay, so there's our problem. So that's the solving of it. Now, if we want, or that's the writing of the inequality. Now, if we want to solve it, okay, this inequality symbol tells me that it's an and because it's less than. So I'm going to take the opposite of 2,500. So negative 2,500 is less than or equal to X minus 50,000, which is less than or equal to 2,500. I have one too many zeros in there. Okay, then we are just going to solve. So I got to get this X by itself. So we need to add 50,000 everywhere. Okay, so 50,000 minus 2,500 is 47,500. Has to be less than or equal to X, which it told us that's our starting salary, which is less than or equal to 2,500 plus 50,000 is 52,500. So that's telling us our average salary, starting salary, is going to be somewhere between 47,500 and 52,500. 47,500 and 52,500. Okay? So absolute value, big thing to remember. When you have the absolute value is less, that means it's an and. When you have the absolute value great or, that means it's an or. All right.